Hi my dear friends, welcome back to our YouTube channel. This is your ADC Maths. In this class, we are going to see the real application of the Fourier transform, that too particularly complex Fourier transforms. So before going to the topic, I would like just to remind you that what is the Fourier transform of f of x? So Fourier transform of f of x is equal to 1 by square root of 2 pi integral minus infinity to plus infinity f of x into e to the power I s x into dx. So here this is the input variable x. We are going to integrate over the range minus infinity to plus infinity. This is known as the kernel of the transformation. So it depends upon the s. So the output is coming in terms of s only. So because this is the output, I is called the complex number, as you know. That's why this is called the complex Fourier transforms. Clear? And what about the inverse? The inversion formula for the complex Fourier transform is the inversion formula for complex Fourier transform is the input is s, the outcome is x. So what's the inverse? So the f of x, the requirement, square root of 2 pi integral minus infinity plus infinity. This time the input is x, the input is s. So what's the Fourier transform of f of x? So it's nothing but the input. So it is in terms of f of s only, right? And e power I, what is the 1 by I? Is nothing but minus I. So minus I into sx. And this time we are going to integrate this with respect to s, because of this is the input variable s. So the outcome is x. The outcome is x. And apart from that, we have the Parseval's identity. What is the Parseval's identity for the complex Fourier transform? This is nothing but the determined values of the f of x and the output f of x. So what is that? So the Parseval's identity for the Fourier transform is integral minus infinity to plus infinity modulus f of x to the whole square dx is equal to integral minus infinity to plus infinity modulus of Fourier transform of f of x, that is f of s whole square dx. So this is the right hand side, the output variable, this is the input variable x. So already you know it's a mapping between the two sets. One is the Fourier transform, that is the f of x, the output is f of x. So once the Fourier transform exists, then the inverse is possible. The inverse is possible. Is right? So by using these three results, I am going to get the first problem, that is the long answer question number 1. Find the Fourier transform of f of x is equal to 1 in mod x less than a, 0 in mod x greater than a greater than 0. That means the a is a positive constant, and hence deduce that integral 0 to infinity sin t by t dt, integral 0 to infinity sin t by t to the whole square dt. I want to find out these two indefinite interval values with the help of the Fourier transform concept. How? Let's see the question. The first idea is to find the Fourier transform. So how to find the first Fourier transform of f of x? That's the formula is there. 1 by square root of 2 pi integral minus infinity plus infinity. So before going to that, the function is very clearly defined. Minus a to plus a, the function is 1. The minus a to plus a, the function is 1, otherwise 0. Minus a to plus a, the function is 1, otherwise it is 0. So my aim is to find out the Fourier transform. So the Fourier transform of f of x is equal to 1 by square root of 2 pi integral. My function f of x defined with the interval minus a to plus a, because of mod x less than a. Mod x less than a means it is minus a less than x less than a. So there is a limit for the variable x. So x is equal to minus a to x is equal to plus a, and in this interval the function is 1 e to the power I s x into dx. Let us integrate this one. What we will get? 1 by square root of 2 pi e to the power isx, so e to the power isx by is, because x is the variable, I into x is the constant. So x is equal to minus into plus a, so 1 by square root of 2 pi, 1 by I into s into, substitute x is equal to a, we get e power isa, putting x to minus a, we get this is equal to minus isa. So this is equal to 1 by square root of 2 pi, 1 by I into s. It looks like e to the power I theta minus e to the power minus I theta by 2i is equal to sin theta. Is right? In the place of theta is here, we have SA. So by cross multiplying this 2i to the next side, we get this 2i into sin theta. Here theta is SA, so sin SA. So after cancellation of 1i and this 1 root 2, we get the answer is square root of 2 by pi sin of SA by s. So this is the output. As I told you that the output is only f of s only. It is in terms of f of s. The input is x, outcome is f of s. So this is the Fourier transform of the given function. Now I would like to use this idea to determine these two integrals. Let us see that. How to get these two integrals with the help of the Fourier transform of the given function f of x. How? Let us see. So the first one, integral 0 to infinity sin t by t. The first reduction part, to reduce that, integral 0 to infinity sin t by t dt. Right? So what is the value for this one? I want to use the inversion formula for the complex Fourier transform. So by inversion formula for complex Fourier transform, what I am getting that? Inversion formula for the complex Fourier transform is nothing but f of x is equal to 1 by square root of 2 pi integral minus infinity to plus infinity Fourier transform of f of x into e to the power minus isx into ds. Because s is the input here. The outcome is f of x. Already we found the Fourier transform of f of x here. Let us substitute here. What will happen? Is equal to 1 by square root of 2 pi integral s is equal to minus infinity to s is equal to plus infinity. The Fourier transform of f of x is something but square root of 2 by pi sin SA by s. Is right? So this is the exactly the Fourier transform of f of x. What's the left hand side? Is f of x only. Let us see. Into e to the power minus isx, e to the power minus isx into ds. The left hand side is f of 0. That's f of x. But I need only the term sin at, that is sin t by t only. So I think so this looks like this one. So before going to that, can I simplify this? Root 2 will cancel. Root pi is pi, is equal to 1 by pi integral s is equal to minus infinity to s is equal to plus infinity sin of sa by s. I don't want this exponential term. Please keep in mind, I don't want this exponential term because there is no exponential term present in the requirement. So what I suggest you that, can I substitute x is equal to 0? And if x is equal to 0, what happened? This is equal to minus 0 becomes 1. What about the left hand side? F of 0. What's f of 0? So f of 0, can you see the given input? The given input is f of x is equal to 1 in the interval minus a to plus a. So 0 is where? So 0 is between the minus a to plus a. So in this interval the function is 1. So f of 0 is also 1. So when I substitute x equal to 0, the left hand side is 1 and e power minus 0 is also 1. So it is ds. So we almost reached the answer. But here t is there, here we have SA. So what I suggest you that, before going to that, this sin SA by s, sin SA by s, can I take sin SA by s is equal to f of s? Can I replace s by minus s? What will get? We get sin of minus SA by minus s. What is sin of minus theta? Yes, sin of minus theta is minus sin theta. So minus sin SA by minus s. So after cancellation of minus minus we get, it is sin SA by s it is exactly equal to the given f of s. So once f of minus s equal to f of s, what is the name of the function? It's called the even function. You are correct. Yeah, this is called the even function. Once it is even function, minus infinity to plus infinity terminus, twice the time 0 to infinity sine of sa by s into dx. Is right? What about here? 1 by 2. So it is 1 by pi into 2 times. Why we write this twice 0 to infinity? Due to the even is equal to 1. Is right? Now still I don't get my requirement t here. So what I suggest you that take sa equal to t. So can I take sa is equal to t once again? Can I take sa is equal to t? What I am getting that yes, s is equal to t by a. What about ds by dt is equal to 1 by a. Otherwise ds is equal to dt by a. Right? So can I convert this in terms of t before going to that? This is 1 by pi into 2. So 2 by pi can make the reciprocal, becomes pi by 2 is equal to integral. When s is equal to 0, when s is equal to 0, t is also 0. When s is equal to infinity, t is also infinity. Yes, a. What's sa here? Sa is t. Right? What about yes? Yes is t by a. What about ds? ds is dt by a. So I think so. This a and this a cancel. So the output is sin t by t into dt is equal to pi by 2. So this is the answer. Is right? Sin t by t is equal to pi by 2. So that is the answer for the first integral part. 0 to infinity sin t by t dt. But the second one is, what's the difference? The difference is the second one is square. So I am going to use the second part. What is second part? Integral 0 to infinity sin t by t whole square dt. Once again the answer is pi by 2. Once again the answer is pi by 2. How sir? Power 2. So already I used the inversion formula this time. Okay. So I don't want to apply once again the same formula for this question. So better can go for square. Can you see that Parseval's identity? Yes. Parseval's identity makes a square. Square in both these sides. So better we can apply once we have the powers, power 2, even power 4, try to apply the Parseval identity. There is no power at all, even though we can get the answer from the inversion formula, we can try it. So but this time there is no power, so I use the inversion formula for the first integral part. If there is a power 2 is there, so this inversion formula is not applicable, so I go for the Parseval's identity. So the second question, anyhow the answer is same only. The answer is same only because of the Parseval's identity we get square, but the answer is pi by 2. So this time I go for Parseval's identity for the complex Fourier transforms. So Parseval's identity for complex Fourier transform. What is it? As given that minus infinity plus infinity modulus of f of x to the whole square dx is equal to integral minus infinity plus infinity modulus of f of s to the whole square dx. Right? So now substitute the f of s and the corresponding f of x in the both these sides. So what is f of x? F of x equal to 1 in the interval minus a to plus a. So this left hand side becomes minus a to plus a modulus of 1 to the whole square dx. The right hand side is minus infinity plus infinity modulus of f of x. So what is the modulus of f of x? Square root of 2 by pi sine of sa by s to the whole square dx. Is right? This is what we get from the Fourier transform of the given function, the very first concept. Right? Then what's left hand side? The left hand side is, I think so, it is 1 square is 1 dx. So x minus a to plus a, so the answer is 2a. The right hand side, as I told you that sin sa by s is an even function, and also it is under the modulus function. Modulus of any function is also an even function only. So modulus of any function is even function because of modulus means minus x becomes plus x. So anyhow this is the even function. So can we rewrite this minus into plus into by twice that time integral 0 to infinity sine of sa by s to the whole square ds. So what about this constant term? Square root of 2 by pi whole square. This also becomes here 2 by pi. Right? Now this 2 and this 2 cancel. Once again I want to rewrite this in terms of t because of here we have sa. So the same concept, take sa equal to t, s is equal to t by a, ds is equal to dt by a. So the left hand side becomes a, the right hand side we have 2 by pi, that's right. Now when s is equal to 0, t is equal to 0, s is equal to infinity, t is equal to infinity, that's right. Now SA, so what's SA here? T. What about s? S is equal to t by a to the whole square. What about ds? ds is equal to dt by a. Okay. So can I simplify that? We get the answer. Before the 2 by pi is reciprocated, we get pi by 2, a in the left hand side. So here I can fix sin t by t to the whole square into dt. What about this part? We have 1a square. So this a square is coming numerator. This a is the denominator. So this a, this will cancel first of all. And the integral 0 to infinity, yes, right? And once again this a and this a will cancel. So that the final answer is sin t by t to the whole square dt equal to pi by 2 once again. So this is the application of the inversion formula as well as the Parseval's identity under the complex Fourier transforms. Got it? May hope, understand, everyone, you may get this concept somewhat better. Please take care of your health. Thank you so much for watching our YouTube channel, ADC Max. Thank you so much.